Hey math kids, today we're going to talk about implicit differentiation, and I think we'll just jump in with an example. So y is defined as a function of x, and so when we do this, we're going to think of this as y to the negative 1. We're just going to do our basic algorithm. So we bring the 1 down here, y to the negative 2. So we get, I'm going to change this to this, and then negative 1 over y squared dx. Okay. Now what if we have dx of x y squared? We're going to have to do the product rule. So we're going to call this A, call this B. So A prime is equal to 1, B prime is equal to 2y times the derivative of y. So this is where like the implicit comes in. We don't really know what y is, so we can't assume that the derivative is 1, and so we have to write dy dx. That's really the only difference. So we're going to write the first one times the derivative of the second one plus the second one times the derivative of the first one. And we just kind of multiply this through. So we're going to get 2xy dy dx plus y squared. Okay. Then we need to find dy dx. If we're given x squared plus y cubed equals 8. And also if we get x plus x squared y plus y cubed equals 100. Okay, so what we're going to do is we're going to take the derivative of all the pieces. So ddx, so with respect to x. Okay, if we take the derivative with respect to x of this is just what we've been doing the entire unit, and that's just 2x. Now this, because we don't know what y is, we can't assume that the derivative of y is 1. Because of that, we follow the same algorithm, so 3y squared, but then we have to say dy dx. So whatever the derivative of y is that. And then we know the derivative of a constant is 0. Okay. And then what we want to do is we want to solve for dy dx algebraically. So we're going to treat it just like its own variable. So I'm going to first subtract 2x. And then divide by 3y squared. So we're left with dy dx on this side, and that on the other side. Okay? This one, we'll start the same. We'll say take the derivative with respect to x of all the pieces. Okay, so the derivative of x with respect to x is just 1. This is going to be a chain rule, or not a chain rule, a product rule. So we're going to call this A, call this B. So A prime is 2x, B prime is dy dx. So I'm going to just move this 1 down here. So 1. Okay, for the product rule, we're going to do the first one times the derivative of the second one plus the second one times the derivative of the first one. Okay. And now we're going to do this one. So it's just 3y squared. But since we don't know what y is, it's dy dx. And then the derivative of a constant is 0. Okay. Now, what we need to do is we need to get everything. Well, let's see. Let's rewrite this as 2xy. Okay. Now, we're going to get everything that doesn't have a dy dx onto the other side. So subtract 1, subtract 2xy. Subtract 1, subtract 2xy onto that side. So rewriting the stuff that has dy dx. Okay, we end up with that. Now we're going to factor out a dy dx. And divide everything by this. So dy dx is equal to -1 minus 2xy over x squared plus 3y. And when I rewrote this down to here, I left off this squared, which means I left off these. And so that should have been squared. Sorry about that. Okay, moving on. Okay, it says find the gradient of the tangent of x squared plus y cubed equals 5 at the point where x equals 2. Okay, so we need to find dy dx first. So we do d dx. Take the derivative with respect to x of all these. So that's just regular because it's x. This, since it's y, we need our dy dx, and the derivative of a constant is 0. Okay, now it's not equal, that's just what we're doing right there. Okay, now we need to solve for dy dx, so I'm going to subtract 2x. And I'm going to divide okay. And now we're going to take this and plug it in for x equals 2. If we, let's see, so when x equals 2, if we're looking at the original, we get 2 squared plus y cubed equals 5, because we want to find what the y value is at that same point. Subtract 4, y cubed equals 1, cube root, so y is equal to 1. Okay, so x equals 2, y equals 1. We're going to plug those in here. -2 times 2, 3 times 1 squared. And so that's going to be -4 over 3, and so that's the gradient of the tangent of this at the point where x equals 2. If you need additional help, please come to Math Lab. Until then, calculate.